let's recap how to work with arrays. Arrays are really just large containers of variables where we can store more than one variable in the same spot. It's helpful, maybe instead of saying num1 and then int num2 and int num3 and then all the way down to int 100, instead I can say int nums. But the int is an array of ints, meaning it's a whole bunch of them. And how many nums is it? Well, I can initialize this in a couple different ways. I could say it's a new integer array with a certain number of entries. I could say that it has 100 entries in it, or 100 slots to insert numbers. Now remember, arrays are not changeable, so the size that you define from the start is the size that you're stuck with. We call this immutable in computer science language. Immutable kind of means unchangeable. All right, this number is locked in. So for an array itself, we actually have to kind of have a sense of how many storage slots that we want from the start to have enough space to include all those numbers. The other way of initializing an array, maybe I'll do this with a set of, why don't we do it with Booleans? I can have a Boolean array of, maybe I'll have results of a contest of heads and tails, where I see how many heads and tails I get, and the results are true or false that I guessed it right in all the different flips. I can also set up an array with these squiggly brackets after the equal sign, and in it I can put the different list of my results. False, false, true, true. I'm going to be optimistic and say that I guessed it more correct than I did incorrect. And so what this has done is actually built an array of 1, 2, 3, 4, 5 entries. So it's the same thing as saying 5 for the size, except that I already have values inside of it. Let's think for a second about this array up here. What are the actual values inside of this int array? Because I've just created it, I haven't assigned anything to it yet. Well, let's take a peek inside. How do I look at any of the information inside of an array? I type in the name of the variable, or the array itself, and then put these square brackets, and I can type in the number of the slot that's in the array. Recall that arrays start at 0, and they go up to the length minus 1. So this 5 number of entries means that this array has slots 0, 1, 2, 3, and 4. Those are the slots that exist. Or my headset died again. It's being really obnoxious today. So if I take a look in, maybe it's the first slot, nums 0. I'm going to print out the value in that slot and just see what it is that's contained inside of it. The autocomplete's being a little weird here. So let me run this and see what's printed out. And in slot 0, it says the value is 0. What about in slot 1? For this one, the value should also be 0. What about for slot 5? Let's run this and see what happens. And hopefully you predicted that I got an error. And the error has to do with the fact that I have tried to reach a slot that's outside of the range of this array, because the last actual slot is number 4 due to it being 1 less than the length. So 4 being the final slot means that if I run this, I should also get the value 0. Integers, if you don't actually say their value, automatically have their value set to 0. And maybe I'll just make a little note of this here. And you can test this out for yourself. Ints will be set to 0 if nothing else is defined. Doubles will be set to 0.0. Booleans will be set to false. And I think that's about all that we really need to worry about overall for covering the initial setup of things. In this second array down here, I can access some of the results. I'll print out maybe results, and in slot 0, the autocomplete. If I run this here, I will see that I have true printed out, because true is the first slot's result. And in slot 1, element 1, I have false as the result for that element in there. Luckily for us, even though arrays are immutable in terms of their size, their contents are not immutable. We can replace things. Let's see here. This element number 4, or the 5th entry in the array, I can actually change this by accessing it like so and setting it to a new value. Maybe I want to set this to the value of 5. Now, if I take this and I print out the value, actually we'll do it before and after to really see the change here. I'm going to comment out this other one down below. Let's see what the result is. I'm printing out the exact same thing both times, but the first time I'm printing out 0, and the second time I'm printing out 5. How come? Because when I initialize it, it's set to 0 automatically, but now I'm accessing and changing, reassigning the value inside, and setting that value to 4. I can also do the same thing with a Boolean, nice and simply. I'm going to say results. Let's go into our first slot and change this result to false. And so now, if I was to print out this result in the opening slot, it used to be true, but now that I've changed it down here, it's false. So I can edit the content inside of an array. And really, it doesn't matter how big the array is. This array of size 100, really, it's just a matter of now I have more elements to work with. I could just, instead of working with element 4, I could do the same thing to element 66. It's the same logic. I'm just accessing different elements inside of it. Another thing that we can do with arrays, why don't I keep this number array here, is use loops alongside them to really do some good work. It would be pretty obnoxious for me to have to go nums and then the first slot, okay, and then I'm going to set that, I want to put all the numbers up to 100 in this array, and then nums, and then we'll go to slot 1, and we'll set this to 2. Okay, this is going to take forever to add all the entries in. So I could use a for loop to do all the work for me. Int I equals 0, my starting point. Now, what's my limiting condition? Where is this loop allowed to run in? Well, I could just say I is less than 100 for the number of slots that they have, but we want to use generalization to our advantage, meaning that this will always work even if I was to change this number later. And luckily, we have a nice little piece of information that we can use to our advantage here. If I press dot or period after I type in the name of my array, I get access to some methods, some behaviors that the arrays have built into them. And the most important one for us is dot length, which is actually going to tell us exactly the size that it has. This statement says, as long as I am within the size of my array, keep on looping. So if I made it 10, this would be 10. If this is 100, this would be 100. This is always going to be equal to this, beautifully generalized. And I'm just going to go up by 1. So I say I++. What am I going to do here? I'm going to set the entry in my array not of a specific slot, but of whatever slot that's equal to the current loop number I'm on. And I'm going to set it to the value of that loop number. Okay. Now, just to see here, actually, yeah, we'll do this one time here first. Nums, and we'll take a look at the first slot, and we'll take a look at the last slot, nums, and because it's 100 large, we'll look at slot number 99. Let's see what's printed out when I now take a look at the entries in these slots. The 0th slot has a value of 0, and the last one has a value of 99, as expected, because we assigned the number that we were at in the loop to the entry in the slot. I could also put this printout right inside here and just print out nums of whatever slot that I'm currently at. And this is going to allow me to, right off the bat, just kind of see all of the data that I've now populated and entered in. These numbers all represent the array that they're part of, and this array now contains all of these numbers in all of its different slots. So we can use for loops to kind of traverse over an array really efficiently and kind of edit some information inside of here. One last thing to show you, just kind of because it would be a useful thing to know about. What I could do is say if I equals 66, which is my favorite number from my favorite hockey player, what if in here I did something a little bit different? Maybe in here I will set my I to be equal to, now I don't want 66 to be used, so I'm just going to set it to 0. It's It's a very important number to me. I don't want to be wasteful with it by including it in this big looped array. So what it's going to do is it's going to go through and set everything up in the way I did before, but it's going to override just the number 66. And so what that means is now, if I actually print out the nums and the 66th entry, I should see that that one, despite it before being set to the value that it would be 66 exactly, now I've actually, when it's inside of the loop, it's initially set to 66. So I can see that initial printout it was 66, but because of this if statement, I override it, and that final result will be 0. One last thing that I could do to add a little bit more content to this is actually include this break statement that we saw before with our, I guess we saw it in our switch statements. Break breaks us out of the loop wherever it's seen. We saw it before in conditions. It breaks us out of a conditional chain, but it can also break us out of a loop, meaning that I'm going to go through 100 different numbers. But if I hit the number 66, I want to stop there. Good enough. So even though my loop is built to go 100 times, this here is actually going to stop it in its tracks. And take a look. Our loop stopped at 66. Just to make sure this is really clear. It just went 66 times. I only changed this number. Now it is 6. If I hit the number 6, I'm going to stop the loop. Bam. So I have another way of controlling the flow of a loop and kind of interwove it with the array here. But hopefully you have a little bit more understanding of how we can work with these basic arrays to store different types of information and how we can use loops to access and change the contents in a really efficient way.